Multithreading. Multithreading in operating system. A thread is a path which is followed during a program execution. Majority of programs written nowadays run as a single thread. Let's say, for example, a program is not capable of reading keystrokes while making drawings. This task cannot be executed by the program at the same time. This problem can be solved through multitasking so that two or more tasks can be executed simultaneously. Multitasking is of two types: processor based and thread based. Processor based multitasking is totally managed by the OS. However, multitasking through multithreading can be controlled by the programmer to some extent. The concept of multithreading needs proper understanding of these two terms: a process and a thread. A process is a program being executed. A process can be further divided into independent units known as threads. A thread is like a small lightweight process within a process, or we can say a collection of thread is what is known as a process. Application: threading is used widely in almost every field. Most widely it is seen over the internet nowadays, where we are using transaction processing of every type like recharges, online transfer, banking, etc. Threading is a segment which divide the code into small parts that are of very lightweight and has less burden on CPU memory, so that it can be easily worked out and can achieve goal indesirably. The concept of threading is designed due to the problem of fast and regular changes in technology, and less the work is different areas due to less application. Then, as says, need is the generation of creation or innovation. Hence, by following the approach, human mind developed the concept of thread to enhance the capability of programs. Benefits of multithreading in operating system. The benefits of multi-threaded programming can be broken down into four major categories. First is responsiveness. Multi-threading in an interactive application may allow a program to continue running even if a part of its blocked or is performing a lengthy operation, thereby increasing responsiveness to the user. In a non-multi-threaded environment, a server listens to the port for some request, and when the request comes it processes the request and then resume listening to another request. The time taken while processing the request make the other user wait unnecessary. Instead, a better approach would be to pass the request to a worker thread and continue listening to a one. For example, a multi-threaded web browser allows user to interaction in one thread while and video is being loaded in another thread. So instead of waiting for the whole web page to load, the user can continue viewing some portion of the web. Second, resource sharing. Process may share resource only through techniques such as message passing, second sharing. Such techniques must be explicitly organized by programmer. However, threads share the memory and the resources of the process to which they belong by default. The benefit of sharing code and data is that it allows an application to have several threads of activity within same address space. Third, economy. Allocating memory and resources for process creation is a costly job in terms of time and space. Since thread share memory with process belongs, it is a more economical to create and context switch threads. Generally, much more time is consumed in creating and managing process than in threads. In Solaris, for example, creating process is 30 times slower than creating threads, and constant switching in 5 times slower. Scalability. The benefits of multi-programming greatly increase in case of multiprocessor architecture, where threads may be running parallel on multiple processors. If there is only one thread, then it is not possible to divide the process into smaller tasks. The different processor can perform single-threaded process can run only one processor regardless of how many processors are. Multi-threading on a multiple CPU machine increases parallelism.